Hello everyone, this is Aditya, and today we are going to solve an integral of 1 to the power x dx. Now many of you will think that 1 to the power x means 1, so the answer should be x plus an arbitrary constant c, right? But in reality, that is not the case over here. So let's start with the video, but before that, please do like, share, subscribe my channel, and please support this video. Now let's start with the solution. Now, if you all remember that the integral of a to the power x dx is equal to a to the power x by ln a plus c, right? Do you all know how it comes? Let's see it. Now you all can write this expression as a to the power ln of a to the power x, right? Either you can write it like this, e to the power ln a to the power x dx. After that, you can evaluate this expression. Or there's another method. If you don't want to apply this, you all can just assume that a to the power x is equal to t, right? Just assume it. Hence ln of t is equal to x into ln of a, correct? Of course there should be mod, but we have assumed that a is positive, so we don't need to worry about it, okay? And since a is positive over here, so we don't need to worry about it, okay? Correct. So from this we get x is equal to ln t by ln a, right? Which means that dx is equal to 1 upon t into ln a dt, correct? Fine, okay. So now let's substitute the value. So t into what is dx? Dx is equal to dt by t into ln a, right? So t and t gets cancelled, so we are left with t by ln a, correct? Okay. Now what is t? T is equal to a to the power x by ln a, correct? That is what I've written over here. It was just a small proof of it, okay? You can use this also to end up getting this result, right? So either of ways is correct, right? So let me erase this, then we will see this problem, okay? Now in this, let's substitute a as 1, right? So you get 1 to the power x dx is equal to a is equal to 1, so 1 to the power x by ln of 1 plus c. Okay, so what's problem over here? Well, there is a problem. Ln of 1 is equal to 0, so this expression tends towards infinity in real domain, right? So what happens if we extend our domain from real numbers to complex number? Then can we get something interesting in that case? Let's see. So if you all remember a famous result, e to the power I pi is equal to -1, correct? Okay. Now we can have n number of revolutions in this case, but we are neglecting that, right? And we are just focusing on the principal value, right? Okay. So which means that you can say e to the power 2 I pi is equal to -1 square is equal to 1, right? Okay. Now just substitute this value over here, right? In place of 1, right? So we get e to the power 2 I pi raised to the power x dx, right? Simple. Okay. So you get e to the power 2 I pi x dx, correct? Now if you all know the formula, integral of e to the power ax dx is equal to e to the power ax by a plus a constant, then we can clearly write it as e to the power 2I pi multiplied by x divided by 2I pi plus a constant, right? Okay. Do you know how we get this formula? Let me tell that also. E to the power ax dx, right? Okay. So what you can do is that you can assume e to the power, or you can assume ax as t. So you get dx as dt by a. So you get the expression as e to the power t dt by a, which means e to the power t by a, right? And what is t? T is equal to ax, so we get e to the power ax by a. That is right. Okay. Now notice that e to the power 2I pi is equal to 1. So 1 to the power x divided 2I pi plus c. Now notice that since there is no integral sign over here, so 1 to the power x will be 1 only, right? So it will be equal to 1 upon 2I pi plus an arbitrary constant. So when we are checking in real domain, then we are getting the answer as infinity. And when we are checking in case of complex numbers, then we are getting a complex result, right? So it is really amazing. Now you all can solve it for n revolutions also. Like if this is true, then it implies that e to the power 2I pi or e to the power 2n pi I is also equal to 1, right? So instead of I pi, you can write it as I pi n, right? So in that case, it will become 1 upon 2 I pi into n, right? So in that case, it can take infinite values, right? Depending on the value of n, right? Okay. So after that, this much is clear. If you enjoyed this video, then please do like, share, subscribe my channel, and please support this video. Bye bye. Take care.